Look, I have a political shirt on. Kind of. Tonight we're going to talk about a couple things. Actually, I have a few things to talk about. First of all, we're going to take a look at this. This is the thumbnail. So can you see that? Yeah. So hold that up there for a little bit. You can kind of look at. You can pause it so you can kind of see what's going on. I'll hold this up every once in a while. You can see that's the super Richie technical drawing for my sequential twin turbo system that I want to build for the LS. It's all there. I'll hold it up again so you guys can see it. Hopefully it's with the, and I'll try to adjust my manual adjustment camera, manual focus camera in, so you guys can see it. But basically, if you look at the thumbnail, what this is it's a twin turbo setup for an LS. I made this for an LS only because I already have most of the things that are going on there. So we have two turbos, two wastegates, two discharge tubes going into an intercooler, and then the intercooler is going into the throttle body. And what makes this work is I already have the Y pipe doing that works for a single turbo. All I have to do, and so follow along while we're doing this, is I have to add another mount for another turbo. So another exit basically. And I'll do that on the other side. So it will be like this. So right now I already have this Y pipe. It goes to one turbo. I'm just going to add another one over here. And the secret are these things right here. And then we'll also have valves up here on the compressor side. So we'll be able to talk about this a little bit. But the key to all of this are going to be these valves. Because what we're trying to do is we are going to shut off flow to one of the turbos. We're going to direct all of the exhaust flow to one turbo. We're also going to close a valve so that when we have the discharge air, the cold side air going into the intercooler, it doesn't backfeed the other turbo. And the way that we're going to do this is, I think I'm going to be able to use, and I hope that the other people that are out there making videos that use all of my ideas because they have a big budget don't steal this idea. But what I'm going to use here are exhaust cutouts. So they make electric exhaust cutouts. You guys can see this, electric exhaust cutouts that open and close basically a swing valve. And all it does is, if you put an exhaust cutout on your exhaust, it's so that you can bypass all of the restrictive area of the exhaust. If you have a muffler and a tailpipe and all that, they just have a cutout, which works fairly well like on a turbo application, because if you have the exhaust after the turbo, you want it as free-flowing as possible. You want it going through a muffler if you're driving around. A lot of times the turbo quiets that. But on any kind of setup, you guys have these for, hot rods and whatever. And so if we have a valve that opens and closes and opens up another port, what I'm going to use that valve for, it's going to be in one tube. It's either going to be open or it's going to be closed. And what I'll do is, so you guys understand this and you guys can kind of see the drawing here, I'm going to direct this is exhaust from the exhaust manifold, both, either side, it's a V8. I'm going to direct all the air to the small turbo. This valve right here, which is going to be an exhaust cutout valve, basically, is going to be closed. This one will be open. So all the exhaust will go to this turbo. Then when the turbo spools up, it'll push all of the air into the intercooler and then eventually into the motor. It won't be able to go this way because I'll have another, and what I'm going to use over here on both of these sides of the discharge side, I'm going to use a throttle body. I'm going to open and close the throttle bodies. And I don't know how I'm going to do that yet, whether that's going to be manually or I might use an actuator. If I can find actuators to open and close this will be cool because I'll be able to do that with boost pressure or electric signals from the ECU. But we have all the exhaust in the primary turbo setup. We have all the exhaust going to the small turbo. It then provides boost into the motor. The motor gets happy because it has boost and starts making more power. Then at some point, it could be a predetermined RPM. It could be a predetermined boost level. We close this valve going to this turbo and open this valve going to the big turbo. Now, ideally, the transition part is usually the part where the OEMs spend a lot of time making it transition seamlessly. On the dyno, we might not care about that. We might have a big dip and then it comes back up. But at some point, this turbo, the small turbo running with this motor, will make enough power and have enough exhaust energy to spool up this big turbo. When that happens, we stop exhaust flow to the small turbo. We have exhaust flow going to the big turbo. And then we open up this valve so that the discharge air, the cold side air, all the power air goes from this turbo into the intercooler and then into the intake manifold. And when we do that, we open up this valve so that it can flow through, and we close this valve so it can't backfeed the small turbo. So what we're doing is opening up valves, the exhaust valve and the intake valve from the small turbo, and having that work. And then at some point, we are closing those and opening up both valves for the big turbo. So we're directing exhaust energy to the big turbo. So because it's already spooled up, we have a lot more exhaust energy because now essentially it was a turbo motor, a lot more exhaust energy. So the big turbo is all spooled up and happy. Now it's directing air in because we've opened up our throttle valve into the intercooler. It can't bypass and go. It goes up against a closed throttle valve going to the small turbo so that we're not backfeeding that. And then all this wondrous boost just gets happy and goes right into the intake manifold. We have blow off valves on both of them so that when we open and close these valves, it obviously would eliminate any kind of surge that might take place. Honestly, if we close the exhaust valve, the valve going to the exhaust side, it'll probably minimize that anyway, but the turbo will still be spinning. So we'll have blow off valves to eliminate that. But I think that this setup will probably work. And it's also something that I can build because I have all of the things that are necessary. In fact, I have most of the hot side of this thing already. And I already have a big turbo and a small turbo. And I already have blow off valves. So really all I would need to do is I need to get these. I'm going to try to source these electric exhaust cutout valves. If I can get those, I think I can make this work. And I think I can make a sequential turbo system work. And then what I would do is run it. I might not run it with just a small turbo, but I would run it with just the big turbo so we can see how laggy it is, and then run it with sequential thing. I might run it with a small turbo too, but definitely with the big one and then sequential so that we could run it and show, hey, look, it improved it and everything was better, because, and I know already from people that we're going to get comments about, well, just do a compound. I did a compound already. And we know what that does. And we know that can work. In fact, compound LS would be much more common because guys do that a lot. But I want to do a sequential because I've never done one. And before I had done a compound, I hadn't done one on the LS. So I wanted to do one on the LS. So now I want to do a sequential on the LS. And I think that I can make that work with the stuff that I have, building a few extra things. And the key to that are the exhaust cutouts. So our poll for tonight will be will the Super Richie sequential turbo system turbo LS system work as described? So let's see what people think about that. The thing that I don't know about is I don't know how well these electric exhaust cutouts will work. I mean, it only needs to work a couple of times on the engine dyno. I could do this manually with Morse cables or something, but it would be better if I could actually do it electronically. That kind of would be cool. So if I can find actuators to open and close, basically what are throttle bodies, that would be cool too. So let's see what guys got going on here. Sequential turbos, the LS Wizard. Compound boost, yep. Compound it has already been done, so. Burns is in the house. Admiral, Brent, Big Block 540, running twin turbos in the mud truck. Goal is 1,300 horsepower. Question, how wild do you have to go on heads? How far can you go with stock before you need cathedral port? I don't know what you mean by cathedral port. Do you mean rec port heads? What heads do you have on it? And how much NA power are you making? 1,300 horsepower in a big block is not hard because it's pretty easy to make 500 or 600 with, and especially with a 540, with almost any kind of 540, even with mediocre heads, it's pretty easy to make 600 horsepower. Admiral, you're liking the design? We'll need one-way valves on compressor outlets. Yeah, we went over that. I've got throttle bodies on that. Admiral, I have a napkin you should see. Yeah, I originally did that was going to be the title of the napkin one, but I just drew it on a note paper. Napkins work too, though. I have an old exhaust design with no less than 3 separate exhaust cutouts. Why do you need 3 exhaust cutouts? Are you doing something with it? The problem is the big turbo isn't spinning just before switching. Yeah, we'd have to. The ideal situation, what they would do on factory sequential systems is they would start opening and closing the valves not all at once, like I was talking about doing, but you would have it start feeding and start transitioning over. My experience with electric cutouts is they open and close really slowly. It might be a bit of a problem. Actually, in this situation, if we can have the valves open and close, and I'm hoping that they work under what is probably going to be more pressure. I'm hoping that if they open and close slowly, that actually might be a benefit in this situation so that we can start getting exhaust energy to the big turbo. Throttle body vacuum sliders and solenoids for dual length runners. Yeah, I have a slider deal that I did long time ago, but I've always wanted to use actuators for it. I even thought about using the little, like little slot car electric motors for it. On the intake side, electric throttle bodies can be wired in an on-off manner. Won't seal 100%. Yeah, but we're not really interested in sealing 100%. It doesn't have to seal all the way. We could have a little bit of outflow, like on the compressor side. That's not a big deal. QTP electric solenoids take about 4 seconds to open or close. That's okay. That's probably okay. That's probably a better transition, I'm thinking. You guys will probably see another sliding trumpet intake manifold before too long here. Love to see a small turbo paired with a large one. That's what this is. This is actually you can't see it too well in the thing, but one of these is definitely bigger than the other in my not to scale drawing. Richard, would you still allow some of the smaller turbo to bypass so it doesn't lose all of its momentum at once on the turbo? Yeah, if we're looking at a 4-second changeover from those, there's enough for the turbo to slow down, and also the bypass valve should allow to depressurize the inlet side of it. The only issue I see is the turbos are not on my small block board. I said that's a problem. Seen it on Smoking Tire 1 takes. There was a compound turbo sub. A compound is different than a sequential. Wastegate control would be a big priority. Yeah, but we have 2 wastegates anyways, and the wastegate is going to be controlling pressure regardless of which turbo we're asking it to control. Think about upgrading my 7875 Gen 2. A VS80 or an 85, depending on how far you want to go. I don't know that an 80 is a giant step up from a 78, 75. Use Arduino or Raspberry Pi to control valves so you can use sensors to match the boost before closing one completely. Gearing can help with the solenoid speed. Yeah, we could put a gear reduction on it. We're running an intercooler on it. Both of the turbos are going to feed the same air to water intercooler, so we're not staging the turbos. We don't need one in between the two and then one after the other one. They're all, only one turbo really is effectively working at a time. Don't forget to hit live chat. I will when I get down to the bottom. Yeah, it's sequential and not compound in. What is your daily? My daily is a 2002 Chevy Silverado truck, and it's all stock. And I've had quite a few race cars, most of them Bonneville cars, although some road race cars, World Challenge, Bridgestone Supercar, and stuff like that. Barrier ram only works because it's a flat six with proper cylinder firing order. So, Sean, you're the guy that makes sure that we don't ever have 100% pull. You must be proud. And now we can go from top chat to live chat. Also, I didn't bring it up here. I ordered the 6-rib pulley for the AMR 500. I got that today. So tomorrow the blower and the pulley are going out to Sweden and to get some dyno testing and some blower dyno testing, and then we'll also do videos and stuff while it's there on the dyno. So that will be cool. Could you use the valve going to the large turbo as a wastegate to start the larger turbo? That's interesting. My original thought was to do this with wastegates, feeding the turbo, but I didn't think that the flow rate of the wastegate was going to be nearly enough. But like I said, we can start when we have lots of back pressure. We can start opening the gate to pre-feed the big turbo. Like I said, the critical thing will be the transition from one to the other. That's the real difficult part. That's like the drivability when you're tuning. That's the hard part. The getting one turbo to work and then the other turbo to work, that's pretty easy. Even with the way that I have this drawn out, so you can kind of see again with the way that I have this drawn out, there's no reason that all of that wouldn't work. Because if you have all the exhaust energy going to one turbo, that's going to work. If you have all the exhaust energy going to the other turbo, that's going to work. And if you don't have a big boost leak somewhere in the system on the compressor side, on the cold side, all of that should work. So this should all work. Getting it to transition between one and the other is going to be the hard part. I would like to see how it would go with a centrifugal. Why do people want to run a centrifugal and a turbo? That a centrifugal and a turbo is like a terrible idea. A centrifugal is not responsive. It makes like 2 pounds of boost down low and then makes lots of boost at the top. So which part of that is going to benefit the turbo? Do you think turbos are safe if rebuilt at home by marking the nut, wheel, and shaft and then assembling it and putting the marks? Yeah, I think they are for what most of us do. Trying to build a 540 big block to make 1,300 horsepower. Want to run twin turbo, Hall EFI blow through, but how far can I take the stock heads, or do you need to go? I don't know what you mean by cathedral. There aren't any cathedral big block heads except for the kind of the stuff that they used on the Gen 7 big block, like the 8.1. So are you using one of those? If not, then you're either using a peanut port, which is a small oval, a regular size oval, or a rec port for a big block Chevy. And aftermarket heads on a 540, if you're wanting to make 1,300 horsepower, would be better than any of the factory heads. Switching between the turbos, I see being the tricky part, definitely. So just to get it to be smooth, like if we don't care about the big crazy middle part that's going to be a big loss in power or something. I mean, if we had it boost actuated, then we could get them to open and close, and then the wastegates could theoretically, if we had controllers on them, if we had a wastegate controller on it, could maintain the boost pressure through the whole time, through the transition time, which that would be kind of cool. I don't know if that's real or not, or if that's me just wanting that to happen. Why not go sequential like they do in the large diesels? That's exactly what this is. This isn't a compound. This is a sequential. School bus 540 8.8 liter heads. Yeah, the Gen 7 stuff, or the PSI stuff, which I still consider the Gen 7 stuff. You can run those heads unless that's the motor that he has. I watched some at the lake pop the charge pipe off their diesel truck and use turbo to inflate a lake floaty. It's good. Are we thinking differently than compound? Yeah, it's not a compound turbo. This is a sequential turbo. This is one turbo working and then the other turbo working, not one turbo working into another one. I use two of the same size turbos on a sequential setup and use an exhaust cutout valve to shut off one turbo, but with a balance tube to connect the two turbos. Yeah, you could do it that way. It doesn't have to be a big one and a small one. It could be two medium-sized ones or two small ones or whatever, just so that you're using, well, you were doing it to have it to be a single or a twin, right? Is that what you were doing? Yeah, if it's a Gen 6 motor, then it's not going to be it's not a cathedral port. I believe it's possible to extend, shorten the runner lengths, or increase blend volume without cam phasing. Yeah, I'll stay out of this discussion. Runner length definitely going to change the power. Plenum volume, not as much. Best Gen 6 heads for you don't need the best head for that. You just need any head. An airflow research head, a trick flow head, a dart head, any aftermarket head will, with the right cam, will allow your 540 to make, say, 600 horsepower. And then from 600 horsepower, it's just boost to get to 1,300. BNR, you ran your Gen 6? The no-name nationals? Could you use one big butterfly that as the transition takes place? I don't know. Where is the one big butterfly going to go? Did you see the drawing? Small turbo have an internal wastegate and the big one an external. Yeah, I didn't think about using an internally wastegated turbo. Both of these are. I have two gates on it, but both of them are external, only because they're already there. Richard, I have a 289 small block Ford retro link bar lifters. Sounded loud. I cut open a set of 302 valve covers. Driver side looks normal. Passenger side, I have one lifter pumping up like crazy. So what do you mean by the lifter is pumped up? So the lifter should be, if it has oil pressure, the lifter should be pumped up. I would do the same thing as Dan with two of the same size turbos and open the second one after a certain boost pressure. Yeah, that's not what I want to do. I don't want to go from a single to a twin turbo. That's not the same thing. That's not the same thing as a sequential turbo. Probably better for flow to have two external wastegates. Yeah, but you see that this Burns, this is this is not like, hey, I want to make the best sequential turbo system that I can. This is, I just want to make a sequential turbo system kind of work. Richard, I won't be able to get the propane stuff. Okay, no problem. One of these turbos that I have, the big turbo, is I don't know, a GT55 or something. It's some big one that Byron sent me. I'm gonna say it's somewhere in the 98 to 105 millimeter kind of thing. It's big, I guess. And then the other ones that I have from a GT20 all the way up to that 55 millimeter. So anywhere in between there, I have something else. I understand how a sequential setup couldn't work with a centrifugal for up top and a small turbo doing work down low. So you're trying to use the turbo to enhance the centrifugal supercharger? To enhance the medium speed torque output of the centrifugal supercharger, which it doesn't have? No valves, both turbos feed at the same time. No, I don't want to use it. I don't want to do a twin turbo setup. Got into sick week and wiped out a cam on my car on the same day. Uh-oh. Went and found some boost actuated Weldon exhaust cutout valves. They're set to fully open at 5 to 7 psi. Yeah, something like that would work. I would close off the one turbo at wide open throttle in less than, say, 2,500 RPM. Otherwise, keep both open. The intake would be a Y, correct? One turbo would feed each port on the Y. Butterfly would go where you collect to feed the intake manifold. Just have to seal off each charge port. You'd have to draw me a picture of what you're talking about. I don't know what you're changing on this design that I already did to try to change something. I don't know what you're trying to. I don't know what you're trying to achieve and what you're changing to try to achieve that. I wanted to chromoly tubing reinforce the frame on my 454 Gen 6 truck. I couldn't get into my buddy's chassis shop. Uh-oh. I'll go and try to put some propane parts together. Yeah, don't hurry yourself because I don't know when I can do that test. So it's not It's not like I'll be sitting around waiting. And October into SEMA looks pretty busy for right now anyways. Any plans for a Gen 5 Big Bang? No, because I don't have a way to get enough fuel to run to the power level that we would want to run very easily on a LT motor. You can easily have 25 pounds of boost at less than 2,500 RPM if the turbos are sized correctly, and carry that same 25 pounds over 7,000 RPM and not go off the compressor map. You're talking about if you have two of them? Yeah, I don't want 25 pounds at 2,500 RPM. I'm not trying to build a diesel. Recal, what's up, man? Yeah, I haven't seen you in a while. In a minute. It's a turbocharged Gen 6 truck. A cam swap be likely for most of my needs, yeah. But a turbo. What's his name? Mike Davis he's got an 8.1, but he's got 300 and something thousand miles on it, and the last 2 or maybe 300 have all been turbocharged. So, and Andy had a cam in it too, and he's driven it and towed with it and done everything. It's worked great for him. How many Bluetooth drive shafts? SEMA stuff is, because a lot of times people get these cars that they get from manufacturers or whoever, and they have a really, really tight abridged schedule to get everything done. And they don't always get the stuff done. It just needs to look pretty for SEMA. Did you see the new engine in Leroy? They destroked it for RPM. Who's Ripley and Hicks? Dude, come on, aliens. It's the only way to be sure. Don't you need to separate the exhaust to the big turbo, block it off till boost comes on at lower RPM? Did you see the drawing? This drawing does that. So we have valves on it. So we have a valve to close exhaust going to this is the big turbo. We have a valve here that stops flow of exhaust to that turbo. And there's also a valve here which stops the little turbo from backfeeding the big turbo. And then vice versa when we close the small one. So there are valves there, both on the hot side and the cold side, to stop flow. No, it's Ripley, who is Sigourney Weaver, and Hicks, who is not Bill Paxton, although he was my favorite. He was also in Terminator. Somebody tell me who his name is. And he was in Alcatraz, and he's great. He's been in a lot of stuff. We do need Ripley and Hicks. That's right. Couldn't see the valves. Yeah, they're all labeled. It says exhaust cutouts. And it says turbo. It says big and small. It is kind of hard to see them. Not Dolph. Michael Biehn. Yeah, that's who it is. It's Michael Biehn. I'm Hudson. He's Hicks. We'll put her in charge. There are 3 dogs actually down there. They're all golden retrievers. That's your ex-wife, Dan. Nice. The problem was that they have 427s that kept bending rods. So were they bending rods because of power or because of something else? Would you be more interested in a specific RPM switch or once a certain boost level is achieved? Probably boost level, because then if we have a boost level, then we would have enough exhaust energy for the bigger turbo to get happy. So it could be a boost level. That could also on the dyno, because the sweep is consistent, it could also happen at a specific RPM range if we wanted it to. Vern, I don't know what the thing is that you keep saying about your oiling. Do you have a plug in the lifter galley somewhere? Navy SEALs, Tombstone, that's right. Yeah, that's right. Navy SEALs goes way back. Having a Buick withdrawal. Weather's getting nice. Time to get it moving. I'm not voting for anybody to be nuking anything forward. It's the only way to be sure. Your dog meat. I say we grease this RFSOB right now. No offense. Nintendo video game. I really didn't play Nintendo video games. My wife and my sons did. They liked Mario Kart. Could you still blow the big turbo like twin charging? Well, you could do a compound blower turbo with a big turbo, and that works too. But that's not what this is. This is a sequential twin turbo setup. Dan, I'm just doing it for fun. I'm not doing it to eliminate lag. I'm going to show in the video that it eliminates lag, which we know a properly done sequential turbo system does. Otherwise, the OEMs never would have done it because it's way more expensive to do that. We know that it works. We know that Toyota did it. We know that Mazda did it. And so we know that it works, and we know that it does exactly that. And that it basically gives you, a broader boosted power potential over greater RPM. It would just be cool. I've never done it before, just like I'd never done the compound one. Well, I had never done it on an LS. I actually did the first compound one I did was on a 1 liter sprint motor. Yeah. So what is can somebody explain to me? I don't build those levels of race motors. I've never built anything with aluminum rods, but why are they using aluminum rods on something like that? Galaga. Oh no, not Nintendo. I guess I get that is Nintendo. Miss Pac-Man. I used to play a lot back in the day. Yeah, sequential like the old Supras or the which is even I like the car even more than I like the Supra. The Supra has way more potential, but the Gen 3 RX-7, the twin turbo RX-7, I like those a lot. Blow a big turbo into a small one like twin charging with a Whipple charger, but still have the block off to the big turbo. I don't know what you're trying. Are you talking about having two turbos and a Whipple? Because then you're talking. It sounds like you're talking about a compound turbo and also having a supercharger, and that's not what this is. The Toyota 3 liter sequential. Yeah, the super stuff was very, very cool. I mean, most guys got rid of it. It is a lot of stuff, but it worked very well for what they were, for the thing that they were trying to achieve. It was pretty successful. Most guys would ditch that and just put a big single in there. I mean, it does look cool. Or you could put a regular kind of twin on there and then have both of those blowing in. FTRX7 is the best. Yeah, I like them better than all the other ones. What upgrades does the VS Next Gen cast have over the base 7875? Well, the Gen 1 7875 doesn't flow what the Gen 2 does. And I don't know about the Gen 3. I don't know. I'd have to talk to Byron to ask specifically what he did. Vern, I don't know if a lifter failed. You should have the same amount of oil roughly, depending on what's the beginning and the end of the where the oil, the way that the oil feed runs. The end of that you might have a little bit less, but you should have oil. Do you have oil? If you have the push rods on all the lifters and you have the rockers all tightened, do you have oil coming up to all the push rods and oiling the top at the rockers? Pushing the crankshaft with aluminum rods with ultra high horsepower stress for high performance engines. Do they change aluminum rods forgive a lot of sins? Do they change rods? Dan, you probably know on Top Fuel stuff. How often are they changing rods on those motors? Are there any good manual trans for an Atlas 4200? Don't they? Aren't there 5 speeds available for those? Make 300M super steel rods. Price is jaw dropping. Yeah, but if you're trying to make 2,000-3,000 horsepower, you need an expensive connecting rod. Northern, we're doing a sequential turbo system. So we're feeding all the exhaust energy to one turbo, and then we're switching over and feeding it all to a bigger turbo. So it's going to be one or the other and not both of them. And we're not feeding from one turbo into another turbo like you do in a compound. That's not what we're doing on this exercise. I have done that before, but we're not doing that on this one. For big horsepower Gen 6 big block, is rec port or oval port better? Or is it still just to get anything aftermarket? It does for you. It's not going to matter for a 1300 horsepower 540 big block. It's not going to make any difference. They have AFR makes oval ports that we've done 1,000 horsepower NA with, so there's more than enough cylinder head, and you don't need the very best cylinder head on a twin turbo big block to make 1,300 horsepower. You could almost do that with just a stock head. The lunar rods will stretch at higher RPM, giving you a little bump in compression. And if they're stretching, they're giving you the long rod motor too, which, as we know, longer rods make more power. Top Fuel guys change pistons and rods every pass. The compressor side is not going to draw air because when we shut them off, we have valves both on to the hot side of the turbo and on the discharge side. So when we shut the small turbo off, we're shutting exhaust energy to the turbo off, and we're not letting it, the compressor side of it, we're not letting that blow air into the intercooler. We're only letting the other turbo do that. We're only letting them do that one at a time. You can get a couple hundred passes out of aluminum rods at 2,000 horsepower. I didn't think that people change them that often, but Aluminum rods do stretch at high RPM. If you don't allow for it, the piston will hit the head. How much stretch are we talking about? Is it a few thousandths? Or is it more than that? And what if you have an aluminum block? Does the block stretch with it? Probably does not. The short stroke crank is much stiffer and stronger with less flex and does not create as much low end torque. That's why they will go faster. So them not making as much torque, that seems contradictory to why they will go faster, unless you're fighting a traction problem. But I agree with the fact that in theory, a shorter stroke crank with less material should be stronger. Restriction from one-way valve couldn't be more than just drawing it through the big compressor. Think Ford 6.7 liter compound, but able to block exhaust completely from a big turbo. You'll have to send me a picture of what you're trying to get me to do. I don't really understand. Think about it. Think about this as single turbo applications. We have a small turbo. All the exhaust energy is going to the small turbo, and then on the compressor side of it, it's blowing all the boost into the intake manifold. Then think about another single turbo, but the turbo is bigger. So we've shut off the small turbo completely. It's not even working. Now all the exhaust energy is going to the big turbo, and then all the discharge from the big turbo is going into the intercooler. None of it's leaking out because it's not getting past the other valve, and no exhaust energy is going to the small turbo. So it's just a single turbo this way and a single turbo this way, hopefully with maybe some kind of successful transition between the two. 20 thousandths clearance. Well, we would have that much piston head clearance anyway, but extra. Okay, that's a lot. Yeah. Richard, you test the VGT turbo. The guys at the car farm have some factory ones on their T4 cars, which came with variable vane turbos. On the Super, the small turbo was always on, just a bigger turbo didn't kick in. How did they stop the bigger turbo from backfeeding the small turbo? If that's the case. Heavy pistons are bad for higher RPM. Got crankshaft deflection going on, also on many engines. Yeah, I found it so funny about us passing. So yeah, Burns, I agree. Especially if they have any miles on them, that's the problem with the T4 stuff. At least, I mean, a lot of that stuff, admittedly, is from the 90s, so it's been around a while. And I'm sure have not been driven nice. And in fact, they didn't even use wastegates on those. They just controlled it with the turbo. But they were supposed to be fairly responsive, and it would be interesting to try it. Nitro's tough on all kinds of parts. We do want to run a nitro methane test. How's our poll doing? 79%. 21% are thinking it's not going to work. I don't want to blow the boost from the big turbo into the small one. I don't want to do a compound turbo. Richard, have you done power comparisons of the Ford 3.8 with an M90 like in the Super Coupe versus the Buick with an M90? No, I haven't ever run a. I take that back. Well, I have run a Super Coupe on the chassis dyno, and we did some modifications to that one, but I haven't done any testing like I have on the engine dyno. Titanium rods need a smooth combustion process. They won't take what aluminum rods do with nitromethane. Has anybody seen any like actual pressure transducer cylinder pressure traces with nitromethane? I'd like to see what the difference is between that and some other kind of fuel like methanol or even gas or even E85 and see, I want to see how aggressive the cylinder pressure traces. It's been a while since I looked, but didn't the Supers have both intake and exhaust throttles to shut off one turbo? I just don't know how you would do it otherwise, at least to shut off. Like, I wouldn't mind exhaust going to both of them as long as you had a diverter where most of the exhaust energy went to the bigger turbo, so it would spool up. I just don't know if they're both connected to the inlet track, how the more pressure and flow from the bigger turbo doesn't backfeed out of the smaller turbo if it's open also. That's one of the things that were in this, cock, cocktail napkin sketch. It wouldn't be compound at low RPM because no exhaust would go through the big turbo. Less rotating mass when you de-stroke and lower the torque in the lower RPM will help traction and pour the boost to it at high RPM. The transducers likely blow up in nitromethane. That would be aggressive then, right? Look at the Camaro Evo 37 and how they did the supercharger and turbo plumbing. You could do the same way with two turbos. You could look at the Lancia Delta too. The Super had turbines in series and the charge pipes in parallel with valves. So it did have a valve to stop backfeeding it. I can ask about Top Fuel, but not. And Dan, no, I'm not really. I mean, Top Fuel is very cool, and that's a lot of cylinder pressure. But what I mean is somebody running nitromethane like on an NA motor, let's say. I'd like to see on, because I'm curious. I want to do nitromethane now, and I talked to Brian Tooley about it. So we're going to run something, especially after seeing Cletus's amazing video. That was very, very cool. But I want to see what the change in cylinder pressure is with the different kinds of fuel. Love how Cletus's ideas are spreading. Hey, let's run nitromethane. I've been asked to do that for a really, really long time. And even methanol, probably more so because I think that it's, more common. But I hadn't ever run either one of them. Yeah, it does. It does bring its own oxygen to the party. That's true. And brings a lot of it. Richard, here's a link. Yeah, it doesn't show links, but I've looked up the sequential thing on the 2JZ. I just been a really long time since I looked at it, but I remembered it having a valve to stop for backfeeding, because we went through the same thing when we had to put two turbos on the Volkswagen when we were doing the Volkswagen project, the Bonneville project for those guys. We had to add a turbo or supercharger to make it qualify for a particular class, but it already had one on there, so we had to add a second one. So we just made a Y pipe and ran the exhaust to two of them. Unfortunately, it was the GSR Beetle, and the head on that new version, the new iteration of that Volkswagen motor, had the common exhaust flange, and I just don't like that. It didn't work very well for our needs. I think I made the exhaust way too big, quite honestly. So do we put a threaded hole in the head and screw in a pressure transducer to measure cylinder pressure? That's what they do, yeah. Vern, I don't, even if I see it, I won't be able to answer your question because I don't know what's going on with the rest of the motor. But yeah, you can send a video, and I will look at it. I saw the Gale Banks thing it's some specific diesel thing that he was talking about. We talked about that the other night on the live feed. Dan, I've seen somebody brought into West Tech one of those transducers that was part of the spark plug, so you could put the spark plug in. After looking at the cost of those, the West Tech guy says, "Yeah, we probably won't be using those." There you guys are talking about the Gale Banks thing. He showed a picture of a cracked block. I don't know if that actually happened because of the studs. I would be interested to see. And we talked about that all the other night about at what situation did that happen, and that's not easy to measure cylinder pressure on something that burns nitromethane. There were guys that rent that stuff. My question to them when they brought it, because I got to see the spark plug, my question to them was, how do you know what spark plug to use? What if that spark plug is too hot for the thing that we're trying to run it on? Because usually something that you're trying to measure cylinder pressure on is going to want a fairly cold plug anyway. So I think that they did air, and I think it was a 3/4 reach plug, which is kind of common. I think they did air on the cold side for the plug design that they were using. So Tim, you're saying that it can be done, and then you're saying it can't be done? You're thinking that it won't be done dynamically, so you're thinking that the transition thing is going to be the problem? Richard, have you tried using oil pressure gauge with a coiled copper line as a turbo back pressure gauge? No, we use on our back pressure, when I measure back pressure, which we do a lot on the engine dyno, we use a steel fitting and then a aluminum tubing that has a flare fitting on it, because we have got a steel flare fitting going into the exhaust, and then that's a coiled section of aluminum tubing, and then it goes to rubber tubing after the temperature goes down, and then goes up to a pressure sensor on the dyno. Well, why Northern? Why do you want to draw through the bigger turbo? I don't understand why. Why is it you're wanting to do it this way instead of the way that it was outlined on the drawing? We don't have any check valves in this situation. We have throttle bodies. And you'd still have to have valves for the exhaust side. So all you've eliminated are, I guess, the two valves on the inlet side. And I don't want the turbo to have to draw through the other turbo. One more minute. I'm going to go ahead and shut off our poll. 78% are saying that yes, it will work, and 22% saying no. The green screen should have an in-car camera going like a rally car. It would be cool if I could put, I don't know how to do that going into studio the way that I go to do the live feed. If I was streaming it, I probably could make that work. Shadow Ops sequentials don't work like that. The compound turbos work like that. Will adding a PD blower make your exhaust louder? Yes. Todd, that's a good idea. That's a good recommendation. Swap the lifters around to see if you have maybe one of those or two of those have lifter boards that are oversized. Vern, I'll put my email address here. It is possible to run the wrong lifters. The band for the oil feed or the band for the lifters could be in the wrong spot, and that band could be coming uncovered on one of these or two of these. Make sure that they're all the same, and it'll allow all the oil to bleed out of one side. Not one side, but out of one lifter. So see if it's coming up out of that. And you could also, like Todd said, measure the lifters and make sure that they're all the same. You might have one lifter that's a lot smaller, enough smaller than the others. Draw through is more of a compound way of thinking. I do want to do a draw through turbo on something, on anything really. I want to do a draw through turbo on something. And I also want to do the what did he call that? I forgot what the name it was. We talked about this on another live feed not too long ago. He has the snorkel ram. That's right. I think that's what it was, the snorkel ram. He has an elbow going into the factory truck manifold with a carburetor on top of it. So I want to try that. I tried it once before, but my adapter for the carburetor was not perfect. I think the way that he did it as an elbow and having the carburetor up above the inlet is a better way to go. And so I want to try that and see if I can make the thing run, to see if it can get like reasonable fuel distribution. And by the way, that's the video that I'm working on tonight. And if I didn't mention at the beginning, I thought that I did. But we're doing distribution, and so I'm showing what the what happens when we run. This is an LS. We run a single plane and a dual plane carbureted, and we monitor the air fuel the way that we always do. We just put it in one of the collector extensions. We have a fitting for it, O2 sensor on one side or the other. Sometimes we switch it from side to side to make sure that they're the same. And then we run it and we tune it accordingly. Well, the problem is, and you see this when you put 802s on it, that even though you're monitoring that and it's taking an aggregate of that bank of cylinders, those 4 cylinders, the individual cylinders are not that. And you can have big disparities. So you have one that's super lean and one that's super rich, and they average out. Hey, look, that's like working out really well. And it doesn't do that. And so I'm showing you that. In fact, it's a 2-part thing because we ran it NA, and then I also ran it with a supercharger as a blow-through thing on both of those intake manifolds. And so I'll show you what happens with the air fuel taken as an aggregate and then the air fuel of the individual cylinders, and you can see how different it is. And then you can compare single plane to dual plane and the aggregate versus the 802s. And then you'll also later on be able to compare that to NA versus boosted. And so it'll be good stuff. VW draw, they used to do draw through stuff a lot. I remember Turbo City going in there a whole bunch. They used to do Weber side drafts in front of the turbos, which was pretty cool. I think a draw through turbo will be like a 671 blower, but much more efficient. It should help. If they're saying that water methanol changes the compressor map of the turbo, fuel going through there should do the same thing. Ripley and Hicks are from the movie Aliens. Smooth plastic runners meant for EFI may not be as good as ported or cast aluminum for wet flow. I think that people put too much emphasis on surface texture because that's not what's going to screw this up. What's going to make this bad is the torturous path that the air and fuel have to make inside a long runner, particularly truck EFI manifold. It's got to go in. It's got to make everything has to go left into a common plenum. And then part of it has to go into the opening of the runners on that side. The other part has to go all the way over to this side under that big tube common plenum, over to this side, and make its way into all of the other runners on that other side. And while air does a pretty good job of that, because people don't envision what's happening with airflow. Air doesn't flow in and go in and turn left and then go in here. Air gets drawn from the common plenum, and then this air going into the throttle body refills, as it were, refills that common plenum. So the air is being drawn in from the common plenum. But when we have fuel there, the fuel has to find its way. And I don't think it's going to do that very well, but we'll see. We'll see. I think that might be the case where you're assuming you're making the small turbo inefficient. Yeah, if we put a small turbo on, the rationale behind sequential turbos like this, a big one and a small one, is that the small one is there to respond, have good response, so low speed power, and then it would eventually run out of steam and not make as much power as we want. So we have a bigger one, so all of it switches over to the big one. You could also think about it like we have a big turbo on our motor and we want to make lots of power. The way that we do that is we use a small turbo to make our little motor think it's bigger and provide more exhaust energy to the big turbo, and then it gets to its happy place. Compounding does that same thing, but it's just, I just wanted to do a sequential. B&R, it might mix gas and air in all those turns. Might help it be turbulent, right? That would be nice, right? Like to see your knowledge on marine applications, low end torque, LS stuff, wet exhaust cams. Yeah, they're just going to be really small so that we don't get reversion in the wet exhaust. Do you think a 5-cylinder really won't run? I think you're meaning with a distributor or a carburetor. Yeah, I remember somebody saying that. I don't understand why that's true. Does it have reversion because of it's an uneven number of cylinders? We know that a 3-cylinder will run with a carburetor, so I don't know that that's actually true. I'd like to test it. Also want to see a boost curve difference between a sequential and a compound. I won't have that because I don't have a true good compound, and I won't have a true good sequential either, but we'll have something. So you're just going to open the wastegate on the little one? No, there's no individual wastegates for the big one and the small one. The big one and the small one are both fed off of the same Y pipe. We're closing the exhaust to the small turbo, so it's not spinning anymore. Why don't you put a carb on a 5-cylinder and find out? What is that?
Don't mind me.
Is that the hardwire for the?
It's my Ethernet cable.
Okay.
Don't mind it.
Might be easier to use a manual cutoff over the electric. Almost feels like they're faking the videos. What if you did 5 Webers on a 5-cylinder? Yeah, you could do that. Well, you could do. Porsche makes it. They make a triple Weber, so you have a triple Weber and a dual Weber, and then that feeds your 5-cylinder, right? That was my son. Cable guy, yeah, he's my tech guy. I haven't done anything with a slant 6 yet. Someone already debunked the 5-cylinder carb thing. Yeah, I don't know how that wouldn't work. A 1-cylinder works, and a 2, and a 3, and a 4. I don't know why a 5 is the only one that doesn't work. Richard, was there another video or information on the Vortec 4200 distributor setup that was run on the propane? No, I didn't ever do anything on his distributor. He did all that. And I think that he used, if I remember right, did he use an early 2J distributor for that? I can't remember. It's been a while since we did that video. I know he had to make some pieces for it, which is pretty cool. Pretty coolio. And on that note, it is time to go. I'm editing the video now on the airfield distribution, and it's pretty interesting. so I'm hoping to get that up tonight. If not, it'll be up early tomorrow morning. You guys will all be able to see it. But I will be back tomorrow. Good talk for you guys tonight, and I will see you all tomorrow.